Hello everyone, this is my fifth video. My name is Ansh and this video is called Elasticity Part 2. So if you haven't seen Elasticity Part 1, I recommend you seeing it, as this is a continuation of that video and you can better understand everything I say in this video if you watch the last video. So let's get started. So last time we looked at elasticity, of course, and we defined that the elasticity of demand is equal to the percentage change in quantity demanded over the percentage change in price. So the same rule can be applied for the elasticity of supply. The elasticity of supply is defined as the percentage change in the quantity supplied rather than demanded over the percentage change in price. And another reason why I recommend seeing the first video is because percentage change isn't as straightforward as it originally seems, especially in economics, since it follows a different rule from conventional maths that you would learn in school. So let's look at just a quick example. So say just for the percentage change in quantity, using the example from last time, say it was 100 to 140, or this example was for price last time, so we'll say 100 pence and 140 pence and work out the percentage increase or the percentage change as in the formula. So rather than doing 40 over the starting number, which is 100, making it 40 over 100, hence a 40% increase in economics, so that we can find out an elasticity that gives us a value for moving both ways along the graph. For example, from 100 pence to 140 pence and 140 pence back to 100 pence, giving us the same value. We look at the average between the 2 points. So say this is point A on the graph, A and B. So say this is a graph, roughly A, roughly B. So then we can work out the average, which is 120, and this gives us a 1/3 elasticity of 1/3. So 0.3 recurring elasticity. So in the first video of elasticity, I've explained this in much more detail, in case you want just slightly more practice. So now we're going to look at a few examples of common types of elasticity, common phrases and terms that you need to know. So now we're going to look at a demand curve with the example of medicine and the price of medicine and the quantity of medicine demanded in a day. Since right now we're looking at demand, the elasticity of demand. So let's take a scenario, and the reason we're doing this is so you can see what perfect inelasticity looks like, and what we're looking at right now is called perfect inelasticity. So say the price of a medicine, starting again, let's say that you need to buy medicine, you live off the medicine for whatever medical condition you may have. Say you're a diabetic, then you need insulin to live, or to at least stay healthy, to be able to do everything to get through your everyday life. So you would need to buy this medicine no matter what the price is. So using this example, as long as the price is reasonable, as long as it's not, I'm going to charge you £2 billion for one packet of insulin. No, but looking at a reasonable example, so we've got here up to £125 for a packet of insulin capsules. So at any point on this graph, if you say you needed one of these packets in a day, you'd be willing to pay whatever price because you need it for this one packet of medicine. So our demand curve will look like this, and we can look at a few points to plot our demand curves. So let's say at £25, quantity with demand is 1. £50, 1. £75, 1. Because this won't be changing. It's not like you need extra insulin on that day, and we're not looking about expected future prices or anything like that, because we're using the ceteris paribus assumption. We're holding all other factors equal currently and looking at the relationship between the price and the quantity. So at £100, we would also only want 1, and at £125, we would also only want 1. So this is what our demand curve will look like. And this demand curve shows perfect inelasticity. It is perfectly inelastic in the sense that inelastic means that it essentially, you can imagine it as if it just doesn't move. It's not elastic like an elastic band, which would be very like, it would be very, the quantity change would be much larger than the price change. So if with a tiny change in price, if I increase the price this much, then it would result in a really large quantity change. But in this example of perfect inelasticity, no matter how much the price changes, the quantity change is zero. The quantity doesn't change. Here, the absolute elasticity of demand, which we can work out, we can say point A and point B, and we can work out here. So for the price, I can write this a bit bigger. The price and the quantity, price is 75 and then 100. And then the quantity demanded is 1 and then 1. So with the change in price being 25 over an average of 87.5 times the difference of 0 over 1, which is 0, divided by that, which is the same as 0 divided by 0, can't do, times by 0, so it is just 0. No, you can look at it yourself, and you can notice that with a given price change, you can take this to be your given price change, you can take this to be your given price change, but with any given price change, the quantity demanded does not change. There is zero quantity demanded. So 0 over anything, whether it be 0 over 115 or 0 over 15, is 0. So the quantity does not change in a perfectly inelastic demand curve. The quantity demanded does not change. We're going to continue looking at perfect inelasticity, but instead now on the supply curve. So let's say you're a tennis coach and you train people or coach people a certain number of hours per day. In this scenario, 5. And that's the maximum you can do per day. But the thing is, you're absolutely mad about tennis and teaching tennis, and you just love tennis. So you never sacrifice on playing tennis, or since this is the maximum amount of time you can take out for tennis, you can't even spend more time playing tennis. So this is your maximum, and no matter what price you're paid for your work, you would still coach this many hours because of your love for tennis. So let's look at a few scenarios again, very similar to this side. So if you're looking at £50 and that's how much you're getting paid per day, over here it's price paid in pounds per day, you'd still train for 5 hours. Here, 125, still 5 hours since it's a maximum. And 250, again 5 hours. So here you get another vertical supply curve, like the vertical demand curve on the left, showing perfect inelasticity once again, meaning with a given price change, there is no change in quantity. Having just looked at perfect inelasticity, where the absolute value of elasticity was 0, now we're going to look at the other extreme, perfect elasticity. So perfect elasticity. So we'll start by looking at demand, and we're going to construct our own perfectly elastic demand curve. So in this scenario, we're looking at two competing airlines, and for the sake of simplicity, we're going to say that they're in perfect competition, meaning that people are impartial which airline they go to. So this would probably mean that they're the same quality, they're from the same airports, those flights are from the same airports and at the same times, which is highly unlikely, but many airlines are very close to perfect competition, in the sense that similar quality. So now we're going to look at the quantity of tickets demanded in thousands per year, and the price of a ticket in pounds. And we're going to look at a few scenarios to help us. So, assuming that the normal price is £30, and in this normal scenario, the price is £30 and the quantity demanded in tickets is 3,000 per year. So each airline, looking at two a bit different airlines, but this is the demand curve of airline 1. So each airline would get 3,000 tickets, have 3,000 tickets demanded. So if one of the airlines, in this case airline 1, increase their price, we can assume 32. So this we will call scenario A, scenario B, and the next one scenario C. If they raise their price, then all of the sales will go to the other airline, because no one would buy tickets from this airline when they can get the flight from the same airport at the same time with the same quality from the other airline. So no one would buy tickets from this airline. All of the sales would go to the other airline, hence this airline would have 0 tickets demanded. However, if they decreased it to 28, then they would have 6,000 tickets demanded. Let's say that's just how many tickets are demanded in total. So they would have 6,000 tickets demanded in scenario C, meaning that all of the tickets that are demanded from both of the airlines together, since the other airline has kept its price at 30, all of the sales would go to airline 1, as it's cheaper and the same quality. And the idea with a perfectly elastic demand curve is that it's horizontal. And if a demand curve is approaching perfect elasticity, then it's approaching being horizontal. And this is fairly horizontal, but it's not quite horizontal. So we'll look at right now more in theory what a perfectly elastic demand curve looks like, rather than looking at a practical example. So let's say that they increase the price to £30 and half of a pence, or even less than that. So a tiny increase in price, so with a given increase in price, but this can be tiny, can result to an infinite increase in quantity demanded. So with just this tiny increase, let's say 30 point, I don't know if you can really see that, but around 30.01 or 30.001 even pounds. So this is assuming that we're talking in theory rather than practically. There would be no sales because no one would care which airline they went to. They'd just go to the cheaper one, and in this case airline 2 is cheaper when the price of airline 1 has been increased. So all of the sales will go to airline 2, hence no sales go to airline 1. However, if they decreased it to $29.99 or even $29.999, there would be no sales going to airline 2, and all the sales going to airline 1 since it's cheaper. So in this scenario, with B still being the normal scenario, the usual scenario, it would be much closer to horizontal. So much closer to horizontal. And in this case, the absolute value, the elasticity of demand, is approaching infinity. Because with a tiny change in price, there's an infinite change in quantity. Now we're looking at a company that supply both basketballs and volleyballs, and they're right now producing 50-50 of each, so 1,500 per year. Since this graph is price of basketballs in pounds on the left axis, on the y-axis, and quantity of basketballs supplied in hundreds per year on the x-axis. So assuming they're equally as hard/easy to produce, they cost the same amount, and the owner of the company is impartial to which they produce right now because they're at the same price. They're producing 1,500 of each. But say the quantity demanded of basketballs goes up, hence the market equilibrium price of basketballs goes up, they can charge a higher price for basketballs. So all of the ball production would shift to basketballs and none would go to volleyballs. So since not right now we're looking at basketball production at the price of £11, all of the production would go to basketballs. So assuming that 3,000 is the maximum balls they can produce per year, they will produce all of those 3,000 balls as basketballs. But say the equilibrium price for basketballs goes down, they can't charge as much, hence they wouldn't earn as much money from producing it. So they would shift all of the basketball production currently that there is to volleyballs, and hence making 3,000 balls produce volleyballs rather than basketballs, and hence none of the balls would be basketballs, they would all be volleyballs. So you would get a supply curve that's approaching perfect elasticity and is approaching being horizontal. And this is a practical example, but again theoretically, with the tiniest increase or decrease in price, there could be an infinite change in quantity. With the tiniest decrease, the quantity demanded will shift to zero, but with the tiniest increase in price, then the quantity supplied will go infinitely up. So here the elasticity of supply, the absolute value of the elasticity of supply, would be approaching infinity.